This is section 7.3, part B, hyperbolas. Now, just like when we were dealing with ellipses, we can find the eccentricity of hyperbolas. The equation for the eccentricity is still E is equal to C over A. Now, you will need to make sure your equation is in standard form first before you can find the eccentricity. If it's not in standard form, you will have to get it in that form. Now, remember, when we're dealing with hyperbolas, the first value is always your A squared. It doesn't matter if it is the larger or the smaller value. And the second number is your B squared. But remember, the difference with hyperbolas is that C squared is equal to A squared plus B squared. With an ellipse, it's A squared minus B squared. So our C squared is going to be 48 plus 36, or C squared is equal to 84. So when we go to find our eccentricity, it's just C over A. So C is going to be the square root of 84. A is going to be the square root of 48. And our eccentricity in this case is going to be approximately 1.32. Eccentricities for hyperbolas are always going to be greater than 1. If you remember from ellipses, for eccentricity for the ellipse will be between 0 and 1. If it's 0, it will be a circle. The closer to 1 it gets, the more stretched out it'll be. And then once it passes 1, you are now at a hyperbola. We're also going to talk about the discriminants of a conic. If we find the discriminant, this will tell us what type of a conic that we are looking at. Now, the standard form of any conic is ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. The values that we're going to care about are the a value, the b value, and the c value. Now, your discriminant is b squared minus 4ac. If your discriminant is less than 0, so if it's negative, it's either going to be a circle or it's going to be an ellipse. We know it's going to be a circle if your b value is 0 and your a value is equal to your c value. It will be an ellipse if b does not equal 0 or if your a value does not equal c. If your discriminant is exactly 0, it will be a parabola. And if your discriminant is greater than 0, it will be a hyperbola. So we need to identify our values first. The value in front of your x squared is your a. Your b value is the value in front of an xy. In this case, we do not have an xy value, so our b value is 0. And the c value is the value in front of your y squared. Now our discriminant is b squared minus 4ac, or 0 squared minus 4 times 4 times 3. 0 squared gives us 0. Negative 4 times 4 times 3 gives you a negative 48. 0 minus 48 is negative 48. So if we go back to our rules, because this value is less than 0 and it's negative, it's either going to be a circle or it's going to be an ellipse. But if we notice, our a and our c values are not the same. So since a does not equal c, this will be an ellipse. In this case, we're going to look for our x value first, or sorry, a value. Our a value is in front of your x squared, so a is 2. Remember, the b value is in front of xy, so in this case we do have a b value and it's 4. And our c value is what's in front of the y squared, which is 2. The discriminant is b squared minus 4ac. So we can say 4 squared minus 4 times 2 times 2. 4 squared gives us 16. Negative 4 times 2 is negative 8. Times 2 is negative 16. And that's going to give us 0. And if we go back and look at our rules again, when the discriminant is equal to 0, we have a parabola.